Technology. My presentation is really to give you a history of where we're at and where we've been and how we are going to move everything forward. Fast technology, circa 1910, that's how a factory floor looked like. This is a Ford Model T production, lots of manual work. Of course, this was revolutionary at the time, but it is a slow process. You can only build so many cars when you have limited workforce and hands in the mix. This is how fast technology looked like as far as computers go. This guy right here, this is a data center and a computer. It has less power than your cell phone. This guy right here is inputting punch cards. These tapes right here are a kilometer long. They only hold 100 megabytes. If you took pictures last week, you probably took more than 100 megabytes worth of pictures on your phone. Again, big thing, manual work, lots of hands in the mix. This is what machine code looks like. This is how computers talk. Think of it as a board game. Anybody can imagine how to play a board game. A lot of the code, move, push, all this, you're basically moving around the board. And every time the computer does something at the base model of it, you're just moving around the board. Of course, there's data that's being recorded through this whole process. There's one routine right here you can leave, which anybody that plays Monopoly really likes that, because Monopoly, once you start borrowing money from the bank, you'll be there playing for months. Going forward, 1999. This is the first Google computer. This is based on an idea. The idea was to look up online in order to give you the result you want based on how many links there are to a specific point of information. That's how things get rated. And that was the only idea. And how do you make an idea happen when you don't have a lot of resources? You get a bunch of motherboards, you put some hard drives on top of them, put them on some plank boards right there. You can see the planks, it's just basically wood, and make it happen. This is how a factory looks today. This is a Tesla factory. No manual work, lots of wires. Electric cars are probably going to be the future. Maybe not in the next 10 years, but in the next 20 years, that we're probably going to get away from gasoline altogether. This is how an office looks today. This is a computer office. Cell phones, laptops, headphones, and comfortable seating. Of course, there is manual work, but as you can see, people don't really use their hands too much for whatever they're doing there. This is what the Google data center looks like. That's a cloud. When you hear cloud, which is the naming of, which is what the buzzword is, we go in the cloud, Amazon cloud, Google cloud. This is what it is. It's just a bunch of computers that are all the same, but there are ideas that make every single piece of this do something different. This could be a piece of Facebook, this could be a piece of Amazon, this could be, they're just really, this could be a piece of Twitter. You're basically platform independent. And again, low cost hardware running great ideas. This is what code looks like today. Compared to assembly, which I showed you earlier, this makes a lot more sense. It has English words. I'd like to use the word automated assembly to describe this, because that's what it is. You're building automation and an abstraction around something that's machine-oriented, that only machines can understand. Who has written any code? Who has written any assembly code? See, very few assembly code. A lot more people have been exposed to actual automated assembly. So what changed? Computer speed has changed. Capacity. You have more data. Your phone can hold more data than one of the biggest computers of 30 years ago. Automation. Automation is really what changed everything. Removing the part of taking the hands out of the process and putting machines or code. Automated assembly, which is the code as it is today, is what changed the landscape. And inclusion. What do I mean by inclusion? Everybody is in it today. Everybody is included. We don't leave people out of technology. Everybody has a hand in technology. And how does that happen today? Forms. When you sign up for Facebook, for example, you fill that out. You are programming a computer. You're building your profile. You're programming. You might not be writing code, but again, there's an abstraction to it where you're actually building it. You are a developer as soon as you fill out the form. Who has filled out the form? Only Ian hasn't. He likes the command line. DevOps is basically, we want to turn ideas into products quickly. We don't want to have to write code. We want to use forms. We want a server. We're not going to build a rack of systems every time we want to do that. We are going to put an application on something more abstract. Anyone can do it. And the main ingredient to it is automation. We're basically having, from an operations perspective, configuration. That's what we do. We configure things. We don't necessarily put things together. We just configure them. And that all can be abstracted into code. And then development, you can buy a product off the shelf. If you have an idea, you can buy a product off the shelf and make it a reality. Or you can have somebody build it in-house. And that's the merging of the two, configuration management as code. We're basically building an infrastructure which has code as its core. It can be reproduced easily, it can be saved anywhere, you're basically creating the abstraction, you're creating the idea into an easily managed abstract system. So, who is ready to build some apps? Thank you.